Hello, welcome once again to Enmak Academy. This is a continuation to our video on limits. So a recap on what we did last time. We spoke about limits and then we gave a definition for limit as the limit of a function f of x exists if and only if the one-sided limits of the function are equal. So if you solve for the limit as x approaches the number from the left-hand side, and then it's equal to when x approaches the number from the right hand side. If the limits are the same, then the function has a limit. Today we are going to be looking at the rules of limits. Let's dive in. So the first one, let C be a constant, or let it be a constant function, and then A be a real number. So we can say that the limit of C as x approaches A is equal to C. What do we mean by this? So C is a constant function and then A is a real number. So for example, if you have the limit of -10 as x approaches 20, we should have -10. So the limit of any number or any function, constant function, any number, this one is just the number, there is no variable attached to it, so it's a constant. The limit of a constant as x approaches any number is equal to that constant. So you bear this in mind. The next one, if you have the limit of x as x approaches a, so here we do a substitution. Wherever you see this function, we put the value there, a there. So this will give us a. For example, if I have the limit of the function 2x as x approaches -1, this should be equal to, so I do 2 times, so wherever I see the x, I put the -1 there, and that gives me -2. The third one, if I have the limit of, let's say, f of x plus or minus g of x as x approaches a, this should give me, so I take them function by function, so this should give me the limit of f of x as x approaches a plus or minus the limit of g of x as x approaches a. For example, if I have the limit of 2x squared minus 4x plus 1 as x approaches 2, this should be equal to, so I can take them function by function, I can break them down. The limit of 2x squared as x approaches 2 minus the limit of 4x as x approaches 2 plus the limit of 1 as x approaches 2. So this should give us, so we do the substitution. So it becomes 2, wherever I see x, I put 2 there because x is approaching 2 squared. 2 into bracket 2 squared minus 4 into bracket 2. Anytime we find the limit of a constant, is the same constant. Remember the first rule. So here we plus 1, and then we evaluate this. 2 squared is 4. 4 times 2 is 8. 8 minus 8, 0. So our final answer will be 1. So that becomes our answer. Still on the rules of limits, let's take the fourth one. So for rule number 4, if I have the limit of f of x over g of x as x approaches a, this is equal to the limit of f of x as x approaches a over the limit of g of x as x approaches a, where the limit of g of x should not be equal to 0 as x approaches a. So for example, if I have an example like find the limit of x squared minus 1 over x plus 1 as x approaches 2, this is simply, I just substitute. So what I have will be, in place of x I put 2, so that will be 2 squared minus 1 over 2 plus 1, and that will give me 4 minus 1, that is 3, over 2 plus 1, which is 3, and this gives me 1 as my answer. Always know that the denominator should not be equal to 0. Let's take another example. So this can be 1. Another example 2. If you have to find the limit as x approaches 1 of x squared minus 1 over x minus 1, we substitute. So this will give us, when we substitute, look at this example very well. If you have to substitute, you get 1 squared minus 1 over 1 minus 1. And then this will give us what? 1 minus 1, which is 0 over 0. It doesn't work this way. This is a wrong approach. So how do we do this? X squared minus 1. This is difference of 2 squares. Because we cannot have 0 over 0. So difference of 2 squares, we need to split this into its factors. So x squared minus 1 will give us x plus 1 multiplying x minus 1 all over x minus 1. Now we have some common factors. So this and this can cancel out. So we'll be left with x plus 1 before we substitute. So since x is approaching 1, then it becomes 1 plus 1, which is equal to 2. And that becomes our answer. So please you take note of this. Let's take another example. So if I'm to find the limit as x approaches 0 of root of 3 plus x minus root 3 all over x, how do we solve this? So the first thing to do is to rationalize this. So we are going to get the limit as x approaches 0 of root 3 plus x minus root 3 over x, and then this is multiplying the conjugate set of this, so root 3 plus x then plus root 3 all over the same thing, root 3 plus x plus root 3. When I do this, I've not changed the initial function here. It's the same thing, because this can cancel this and I'll get this back. But this is to help us get rid of, to be able to solve the question. So when I do this, what do? I multiply the ones at the top. So it's the limit as x approaches 0 of square root of 3 plus x minus root 3 multiplying root 3 plus x plus root 3 all over x times root 3 plus x plus root 3. Now the top one can be described as difference of 2 squares. So it means I'm going to have the limit as x approaches 0 of, with difference of 2 squares, when I expand this, the numerator here, when I expand it, I'm going to get the root of 3 plus x all squared minus root 3 squared, and everything is over x into brackets root 3 plus x plus root 3. Alright, so with this, the root and then the square cancel out. So I'm going to have the limit as x approaches 0 of 3 plus x minus 3 all over x into brackets root 3 plus x plus root 3. When I evaluate the top one, so I group like terms, so 3 minus 3 gives me 0. So I'll be left with the limit as x approaches 0 of x all over x into brackets root 3 plus x plus root 3. Now x can go into a 0 of 1, x cancels a 0 of 1. So I'll be left with the limit as x approaches 0 of 1 all over root 3 plus x plus root 3. So this is where I now do my substitution. So wherever I see x, I put 0 there. So now I'm going to have 1 over root 3 plus 0 plus root 3. And this will give me 1 over root 3 plus root 3, which is equal to 1 over 2 root 3. You can leave this as your answer, or you can further rationalize this by multiplying both the numerator and denominator by root 3, so that your final answer becomes root 3 over 6. So this becomes your final answer. Let's take one more example. Let's find the limit as x approaches 0 of sine x over, okay, let me use tan. So sine x over tan x. So this will be equal to the limit as x approaches 0 of sine x over, now we know tan x is equal to sine x over cos x. So this is the same as the limit as x approaches 0. So now you have sine x dividing sine x over cos x. So that will be times cos x over sine x. Because when it's division, you change it to multiplication and then you flip the next fraction. So this is what we have. Now you have sine x here, sine x here. So what happens? They will cancel each other. So we'll have the limit as x approaches 0 of cos x. So over here, what do we do? We substitute. So this becomes cos of 0. And cos 0 is equal to 1. So 1 becomes our final answer. I hope you enjoyed this video. Stay tuned for our next video on limits again. We have other things to discuss on limits. We'll be talking about limits of piecewise functions. And then we'll also talk about the squeeze theorem, as well as limits at infinity. So catch you in our next video. Make sure you like, comment, and then subscribe. See you.